the next theory is a plane wall, same plane wall, but this time around you have convection outside and inside the wall. Okay, so this is what happened um, if we have uh, the combination of both modes, okay, in that particular system. Okay, previously you only deals with conduction. Okay, then we will have a convection, either inside or outside or both. Okay, so uh, this it's not a big deal. Okay, it's just that you have to add this layer. Okay, this layer of resistance. So it's just like you have a layer of in convection, just a layer of conduction inside, and the layer of again convection. So R convection inside, R convection outside, convection, and then R conduction. Okay. So you can always go for depends lah. How do you want to design it lah, ataupun to put the punya unknown ni apa. Okay. Nak tahu RA, RB, RC pun can also, no problem. Okay. So the thing is the difference between convection and conduction is if we have convection R is basically 1 over H I A. So luckily this time around the A is the same, okay, because the height is the same. Okay. And then it's just the same lah with RI, and it's just the same with RO lah, HOA. It happen to be the same A. That is why when you plug out the value of A, okay, in this R ni, it will become U. Okay, it will become U. Okay? A tak ada. Okay, so this is a new type of equation lah. So this one is basically the equation, the coefficient that represents the overall heat transfer coefficient. We call it overall heat transfer coefficient. Okay. So to state that, basically your system have the convection coefficient, conduction coefficient. Okay. Then it turned out to be the overall coefficient that represents all the modes in the heat transfer. Okay, and normally you will find this in heat exchanger calculation. Okay, so for the purpose of conduction, okay, because this is a chapter of conduction, so we are emphasizing more onto conduction lah compared to convection in that sense lah. Okay, we will have special chapter on convection after this. Okay, so for the time being, we might want to ni lah, we might want to stick with conduction dulu lah. Okay. So just use this equation lah. Okay. Unless kalau dia require you to do this equation, then you have to do lah. It's just to plug out A je, and it happen to be A yang sama. Okay, A untuk ni sama, so kalau you keluarkan pun tak ada masalah. Okay. So dia jadi U je lah, so tak ada masalah. Okay, macam ni je. Okay. Dan akhirnya you kena darab dengan A juga kat luar ni kalau nak dapat Q. Right? And you have our wall is equals to usual ni lah, KA. K ni is if one single wall je, you have K je lah. Because these two tak ada K, apa pun. Okay. And then when you try to, because you will be given T1 and T4 normally, okay? So you will try to determine the temperature inside and outside, okay? Inside and outside the wall, okay? So you can either use ni lah, this equation for number 2, atau this equation, dua ni, untuk number 2, atau this equation dan this equation untuk number 3, T3, okay? T2. So you can use Q sama dengan P2, okay, sorry ya, T1 minus T2 sama dengan Q over HIA kan. Okay, so T2 is T1, T2, you want to determine T2 is T1 minus Q over HIA. Okay, atau T2 sama dengan T3 plus Q over delta X over KA. Okay. Dan tak ada dua ni lah. Dan begitu juga T3 dan sebagainya lah. So, you have to refer to the layer. Refer to the layer. Okay. So, because T2 is in between layer convection and layer conduction. So, it's either one lah. Then you can determine T2. Okay. If the question requires you to determine T2. Okay. If not, then you leave it as it is lah. Okay. Sometimes they ask you to determine or to calculate or to estimate the value of Q saja. So don't have to go that far lah kalau tak disuruh. Okay. It's the method lah for you to be employed, okay, in the solution. This one is for cylindrical wall. Okay. Because of the A, okay, of the cylinder might be different, which depends on the value of R. Okay, that is why for overall heat transfer coefficient, you will have two U. Okay, it's either you want to make it in the form of UI, whereby you plug out AI ni from the equation, so that will leave this term jadi paling simple lah. Okay, whereby there's A1, AI ni will turn out to be being transferred to other terms lah. Okay, ni AI ada kat sini dan AI ada kat sini. If that will be in the form of UI. Kalau in the form of U node, okay, so it will become A node ni berada di sini dan ni jadi simplest form lah. Okay. So because of different R, so that is why UI, they will have UI and U node. Okay. So basically this one is also related to, this one is much more related to heat exchanger juga. Okay. Whereby you have annulus lah normally. Kat luar ni sebenarnya adalah satu lagi layer. Okay. Maksudnya yang ni adalah pipe-nya thickness. Okay. So yang ni ada, dalam ni ada fluid. Okay. Dekat luar ni pun ada fluid juga. Okay. Kalau heat exchanger normally macam tu lah. Okay. So dia cakap, dia panggil annulus. Okay. So yang ini dia tak anggap, kalau untuk sistem ni dia tak anggap ni lah. Dia tak anggap sebagai annulus tu. Okay. Dia anggap sebagai persekitaran je. Okay. Maknanya mungkin ni bare pipe. Okay. Pipe yang tidak ada insulation. This one is being exposed to the environment. That's it. Okay. Tapi kalau dalam heat exchanger dia ada satu lagi layer yang dipanggil annulus lah. So annulus tu adalah tengah-tengah ni ada fluid. Okay. Okay. This is the example. Okay. Whereby you have this time is very hard. It's quite hard. Because we are not used to this kind of unit sebenarnya. Okay. Because the unit is in this one is being called British unit. Okay, so this British unit is quite different lah compared to what you have been applied so far, which is SI unit. Okay, so but you don't have to be worried about that lah. Okay, it's just that you have this unit ni saja yang you nak kena cater. Okay, so you have to convert inch tu kepada feet. Okay, because the H and also the value of K, okay, is determined by the unit of feet. Okay, so we have R in unit of inch. We have to change it to feet lah. Okay, I think inchi to feet, the factor is 12. So 1 feet 12 inch. So 1 inch you just over dengan 12 lah. Bagi dengan 12. Okay. So check balik nanti I think betul lah tu. Okay. So saturated steam at 267 degree Fahrenheit is flowing inside a 3/4 inch steel pipe. Okay. By right, this one, don't be confused lah. This one is basically the pipe rating, or the name or the commercial name of the pipe. Okay, the pipe is 3/4 inch. Does not mean that the diameter is 3/4 inch. Okay, so the diameter is being given by this. Okay, 0.824 inch. Okay, but the grade is 3/4 lah, 3/4 inch. Okay. But basically, is 0.824 inch internal diameter. Okay, and OD is 1.5. So you just write as R1. Okay, R1 lah. So sama dengan 0.824 over 2. Okay, then you dapat jawapan ni, you kena bagi dengan 12. Okay, ataupun you darab dengan 12 pun kat sini pun boleh tak. Okay, untuk tukar kepada feet. Okay, dan R2 pun samalah, 1.0 over 24. Okay, and then the pipe is insulated with 1.5 inch of insulation outside. So R2, R insulation. Okay, you buatlah R2 plus dengan 1.5 inch bagi 12. Yang ni jangan bagi 2 thickness. Thickness, this one is thickness. So don't have to divide by 2. Convection outside, inside is HI, outside, inside 1000, outside is 2. Okay. Normal lah, this one is ambient ni, dia punya range dia dalam 2 to 25 watt per meter square uh, dot k normal ni no julat ataupun range or the ambient lah, ambient convection. Okay. This one is process convection 1000. Okay. Kemudian the mean thermal conductivity, okay, so KA sama dengan 36, AB sama dengan yang dua silap, dua ni is BTU yang ni dalam minit watt jangan terkeliru lah, and 26 and 0.037. Okay, this is KA KB. And then calculate the heat loss for 1 feet. So L is 1 feet. Okay. So you have been given all the equation. Okay. So the system is number one, you have to answer what is the number of layer. Then nah, this one dia tak suruh pun you calculate suhu kan. So okay lah, senang lah. Okay. So layer ada berapa, and then apa lagi ya, layer, then you punya R lah. Okay. Layer will determine your R. But this time around, they do not tell you what is A, what is B. Okay, so but you always know. You have pipe and insulator. Yes, you are right. Okay, this one is both is one of the layer lah. So you have conduction. You have another conduction. Okay, conduction for pipe, conduction for insulator. Okay, but you must not forget the convection. Okay, convection. So convection dia ada convection outside dan convection inside. Sebab tu ada H0 dan HI. So how many layer that you have? Berapa layer?
4.
4 layers. Okay. So you ada 4 layers. So bila ada 4 layers, this one is referring to convection. But you have to be very careful lah. Kalau HI tu are referring to inside, so HI you tengok HI lah. Kalau H0 tu referring to outside, so you tengok H0. A0 and AI is different, okay, because different in radius. Okay, and might as well a log mean lah ataupun ln R ni, ln over 2 pi KL. Okay. Ln over 2 pi KL. Okay. So how to solve this equation is by determining each R, okay, have their own R. So for convection, R dia is 1 over HI AI. Okay. So AI ni beritahu lah dia adalah pi R RIL. Okay. So yang ni delta X over KA ln R ataupun apa namanya macam ni ataupun ln R2 over R1 over 2 pi KL. Okay. RI bagi R0 lah. Macam tu. Okay. Dan yang ini ln R insulator bagi R0. Okay. 2 pi K insulator L. Yang ni K pipe. Okay. This one is 1 over H0 A naught. A naught ni adalah R dia adalah R insulator 2 pi R insulator, bukan R naught bukan R2 R insulator. Okay. So kalau you lukis sistem tu, this one is pipe. Okay. So ni pipe ni dia ada OD dengan ID ID dan OD So OD kat luar. Okay, OD. Yang ni adalah ID. Okay. Kecil ni ID, yang besar ni OD. Then you have another layer of insulation. Okay. So thickness ni, yang ni adalah R insulation. Okay. R insulation. You ada R internal, R outer, dan R insulation. So this one is referring to R insulation. Okay. Jangan ada separuh yang terkeliru dia buat R naught. Maknanya dia sampai setakat sini je. Salah lah, dia kena termasuk insulator sekali sebab we are talking about luar. Okay. Yang kat luar ni, radius kat luar. Yang satu lagi kat dalam je. So yang ni, that's why dia RI. Dan ni paling luar dan ni paling dalam. Okay. So once you get R, all R ni, RA campur RB campur ni, you dapat summation of R. So the temperature is already been given to you. And also this one. Okay. So cumanya mungkin dia punya convection dia proses dia tu dia berlaku sebaliknya lah. Maksudnya dia daripada dalam dia pergi keluar. Okay, daripada dalam dia pergi keluar lah. Maksudnya the temperature on the higher side is inside the tube, the cylinder. Okay, while outside ni is 80. Inside ni 267 So it is outward lah. Dia pergi keluar lah. Dia punya direction dia. Okay, direction dia keluar. That is why dia sepatutnya nilai dia sepatutnya negatif lah. Okay. No, supposed to be negatif lah. Because TI ni, tapi boleh juga. Kalau jadi positif pun boleh juga sebenarnya. Sebab T1 ni kalau you anggap 267 dia jadi positif lah. Tempat ni you anggap dia you anggap dia kat luar, okey lah, betul lah, boleh lah, dia jadi positif lah sepatutnya. Okay. So this will be the answer. So please check the answer whether betul ke tak. Kalau you tak dapat ataupun kalau salah, kalau you dapat jawapan lain, you beritahu